So hey guys, we are back with another video, and in this video we are going to talk about LLMs get lost in multi-turn conversation paper. So this paper has been viral over Twitter for the last 3 to 4 days because of what they have revealed, and it's an interesting paper. I would recommend each one of you post this video, go and read this paper in detail because it actually exposes a lot of things of how models have been trained and how we are actually over relying on LLMs, specifically when it comes to some important tasks which can be done by us in lesser time with good quality. Yeah. So let's start what this whole paper is all about. So the main focus part is that LLMs are conversational interfaces, obviously, and most of the time when you want to use a LLM for something, how do you usually use? You will go to ChatGPT, you will go to Claude website, or you will go to Chat Gemini, right? You won't be sending it through API, right? You won't be sending a single message to the API and through an API call and then ask it the question. Usually you won't be doing that, but you will be going to the chat interfaces, right? Second thing is you will ask one question and maybe ask it to do a task for you, and maybe an interrelated task you will ask it in the same conversation. Else you will think I'll have to go to another chat conversation history, a new fresh chat, and from there I will have to give it context and then ask the question, obviously. So it makes sense to put the interrelated query there on itself. But what if I tell you this is actually making your results worse, and this can be improved by sending all the tasks that are like correlated to each other in a single prompt. So this is what this whole experiment is about. That their experiments that they have conducted show that all the top open source models exhibit lower performance in multi-turn conversation than single turn, with an average drop of 39%, guys. This is not a small number, 39%, right? And they have analyzed more than 20 lakh simulated conversation that decomposes the performance degradation into two components: a minor loss in aptitude and a significant increase in unreliability. This is where the whole game starts. So let's what it can look like. Usually you can give the whole thing, please generate, I need this, I need requirement of this, also requirement 3. You can give all the correlated thing into a single thing. Second is multi-turn interspliced, right? Under specified conversation, that you will give one thing, okay, I need this website to be like this, model has coded, now I want these things to be added, model will again do it, third thing, fourth thing, something like that. But this conversation is maybe not giving you the best output if you could have specified all the things together in a single one. Let's go to another. So let's see. They are saying the introduction goes like this, that today's LLMs function as a conversational interfaces, as we have already said. ChatGPT, Gemini, Claude all have their interfaces, right, where you go and chat. But what the whole concept is that in this work we close this gap, this multi-turn fashion gap, that most of the time we will do task in a single interface, right? But we identify in a review that most prior work treats the conversation as a episodic. Conversation turns might relate to each other, but the conversation can effectively be decomposed as an array of subtasks that can be evaluated in isolation, because the models have been trained like this, right? So let's see what they have thought of doing this. So they divided the whole thing into the simulated conversation part. So they divided the whole thing into four to five type of queries. We'll go to the simulation types, 1, 2, 3, 4, 5 type of queries, and they tested on it. So how a fully specified instruction look like? Jay is making snowballs to prepare for a snowball fight with his sister. He can build 20 snowballs in an hour, but 2 melts every 15 minutes. How long will it take before he has 60 snowballs? And these sharded instructions, which we call sharded, can be one by one, right? Shard 1, how long before Jay is ready for the snowball fight? So then you will have another set of information from that. He's prepared, because whatever the output of model is, now you're going to provide the other information. He's preparing for a snowball fight with his sister. He can make 20 snowballs per hour. This is the third shard that you're giving to model. So it goes like this. This is the user simulator. The simulation starts. You reveal as the first shard. Whatever is the generated, it will go to this clarifier, this clarification, and then on the basis of that the other shard will be given, right? So, and at the end, when no unrevealed shards are left, you will end the simulation, right? And this whole thing will be evaluated, that correct or incorrect. If it is correct, you will automatically end the simulation. If it is incorrect, if you already have something left, or if any of the shard, you're going to again give it to the user simulator. Okay, so on the first run, the user simulator reveals the first shard, that is how long before Jay is ready for the snow fight. which then generates a free text response, the system processes the assistant response into one of the 7 possible strategies. It can be clarification, it can be refusal, that I'm sorry I cannot answer, it can be hedging, it can be interrogation, discussion, missing, or answer attempt. Based on the LLM's response category, we are going to proceed to the next step. So if the assistant generates an answer attempt, let's say proposing an explicit full form answer, then the answer extractor components determine the span that corresponds to the answer within the assistant's free form response, as we already decided, like discussed in the whole architecture flow. Now let's say which model is going to decide this. Okay, so I think they decided that because this experiments that we will be doing, evaluate assistants often ask clarification question that related to specific shards of the instruction. As such, deciding which shard to reveal next in the conversation, it should take into account the state of the whole conversation that has been going, right? Because based on what question the LLM has asked, we can provide it the next shard. Now we initiate the user simulator as a low cost LLM. So they have decided GPT-4o as the low cost LLM for this whole user simulator, and it completely makes sense because this user simulator is majorly for deciding which next shard to go. So we don't need to have a very big LLM for this, because a single LLM can, a very small LLM can also do this. This is not a very complex task, right? So GPT-4o mini, I personally feel it's best. They could have gone with GPT 4.1 mini, but it's their call, right? Now, apart from user simulator, the strategy classifier and answer extractor components are also implemented with the prompt-based GPT-4o mini. Okay, the strategy classifier and the answer extractor is also based on GPT-4o mini. So they have decided this whole flow will go with GPT-4o mini as the decider and simulator model. Okay, now they have divided the conversations into 5 type of queries, right? The first is fully specified, which I already showed you. Jay is making snowballs to prepare for a snowball fight with his sister. Second is sharded, that is simulate multi-turn unspecified conversation. I think you guys can see also this full sharded, right, one by one. Then you have concat. What is concat? So suppose these 5 conversations are there, right? You know these shards are concatenated into a single instruction in bullet points form, 1 shard per line. Let's say this whole shard, instead of a paragraph, you can have 1.1.1.1, but in a single, okay, something like that. Then you have a recap, that it simulates a sharded conversation and adds a final recapitulation of what was happening, and then in a single turn, you're going at the last turn, you're going to give all of the things together. In Snowball, every time the task that has already been revealed is going to be revealed to you again. So let's say shard 1 was revealed, when shard 2 will be sent, shard 1 along with that will also be sent. Shard 3 sent, 1 or 2 can be sent, something like that. Okay, so these are the 5 type of things that they decided to divide the query type. I'm really so appreciable to these guys. I want to appreciate them because they have decided to not only experiment on this sharded instruction, but also on concat, recap, and snowball. And it's a good thing because similar things doesn't always means that you will get similar results in LLM. That is what we have seen, right? That even if the flow is similar, things look similar, doesn't mean they will generate the similar results, right? So let's go to the next part. Correct. So I think you guys can see this sharded instruction. This is the whole thing. You have divided, right? Sharded, fully specified. So 5 type of tasks are there: coded, database, actions, math, data to text, and summary, right? Summary, I'm really interested because I usually work in this field. So yeah, although I'm excited for the whole thing, but it's fine. So these are the 5 tasks. You can see code, database, action, math, data, summary. Now for metric selection, it's a very important thing, right? They employ a stochastic process to generate text. When setting LLM generations to their default, that is temperature of 1, I think they are giving that as an example. LLMs generate many distinct responses for a fixed conversation state. We leverage this property to conduct repeated simulations for a given instruction and observe the variations that occur. Each simulation yields a score SI ranging from 0 to 100 that assesses the level of success of the LLM in completing the task by the end of simulation. So based on these set scores, we obtain the running and simulation for instruction. We define 3 matrices: average performance, aptitude, and unreliability. Makes sense, completely makes sense, right? Because these are the 3 tasks that we are things that we are focusing at the end. That okay, how reliable a model is, what is the average performance, and what is the aptitude. So average performance is an unbiased estimate of a model's mean score on an instruction in a given simulation type. That is 90 is an estimated of a model's 90th percentile score on a given instruction. A best case metric that estimates scores obtained in the top 10%, right? So it completely makes sense that you want to because rely on the model's 90th percentile score on a given instruction, estimate of a 90th. So okay, now unreliability is an interpercentile range estimate between 90th and 10th percentile estimates, measuring the gap between best case and worst case simulation, giving a sense of level of degradation that occurs in response quality due to stochasticity of the LLM. Completely makes sense, right? I think now we can move to the next part, which is simulation scale and parameters. Okay, I think they have selected 15 LLMs: OpenAI, GPT-4o Mini, 4o, O3, O4, GPT 4.1, Claude 3 Haiku, 3.7 Sonnet, 2.5 Flash, 2.5 Pro, Meta, Llama, DeepSeek R1, Coher's Command A, a lot of hell of LLMs. Okay, now let's see, guys, what is happening here. I think, yeah, so 3.18 billion is having a degradation score from 27.5 to 21.7. So if you guys are thinking this is less, you need to see the other models. Gemini 2.5 Pro, which Google just said to be the best state of the model in the industry, was in full for Python. Okay, for the code part, let's say. For Sharded, it got 68.1. Guys, a 30% whooping decrease. 30% decrease, right? Similarly, 97.3 in database, 43.8, more than 54% decrease. Guys, this is the reality of LLMs. Things that look similar are not similar, right? Even if you see 97.3, we have got a degradation to 94.9. We divided the whole prompt into concatenated strings and still got a degradation of 3%. No one knows why. So if you see, whole this thing is turned into red. Only minor, I think, 13, it was already 13, so I think how less it could have been 13. This was already 23, 27, and all of this whole thing is turned into red. Big thing, guys, right? Big thing that we still don't know, because of interpretability not being into focus for a long time. We still don't know that what our LLMs are actually capable of and what they are not, because they are trained in such a way, guys, that maybe they are better in a single chat conversation rather than multi-turn chat conversation. So this is the thing. Now let's look at the result. Every model sees its performance degrade on every task when comparing full and sharded, with an average degradation of 39%. Guys, this is an average. We name this phenomena lost in conversation. I think after lost in the middle, we finally got lost in conversation. Models that achieve stellar 90% performance in the lab-like setting of a fully specified single-turn conversation struggle on the exact same task in a more realistic setting when the conversation is under-specified and multi-turn. So I think with concatenate, the performance averaging is 95.1% of the full counterpart. This is fine. This can be considered, because if you see, I think this is average is fine. See, guys, 5-10% you can say, okay, that okay, maybe because of training part and that thing, that difference is there. But 39% is an average. We'll have to question a lot of things here. Now, in concat performance, I think I won't say much because the results look decent. But for the sharded part, we can clearly see the models are not performing that good, right? Now let's see the last, this visual introduction to the concept of aptitude and unreliability overlaid on a box plot visualization. I think what is left to see now, you will see if you see visual aptitude and unreliability, gradual sharding results, observed model degradation. You will see a lot of degradation, guys, a lot of degradation every time. Just see in the top 3 models you can see. For Llama, you can say Llama I won't consider because it's a 8 billion model. Let's see Gemini 2.5 Pro, guys, 50%, right? You can see the sharded 50%, 2271. It's a big number. Then you can see 68 to 83, 15%. So this reliability based results, right? This observed model degradation is a lot. What are you or me as machine learning engineers going to interpret from it? That a lot of things are still unknown and we still need to work a lot on these things, right? Because consistency is the only thing that we demand from a large language model to achieve AGI, right? Consistency, and that we are not getting here, right? For the similar type of task in a different way, right? So yeah, that is one thing. Now let's look at what the final say. This results confirm even models like O3, DeepSeek R1. So guys, why are these models into existence? Reasoning models, thinking models, why are they into existence? Because these models should prove that, okay, we are good in thinking, and we, for any complex task, we are going to think, and then we are going to generate a reply. Is that thing happening here? Let's look at DeepSeek R1. DeepSeek R1 is here. 99 to 79, 71, 28% degradation. I think 92 to 31, 60% degradation. How can we even say that? O3, which is, should be different than 4.1 because of its thinking capability, but it's not. 86.4 to 53, 33% degradation. This can confirm additional test time compute does not on its own allow model to strategize over multi-turn conversation for sure. Maybe it's good in maths because it has been trained on that, but for this basic thing, multi-turn conversation, it is not at all doing good. It's a very basic conversation is a thing that I think companies thought as the first thing while building a large language model, that there is going to be a proper conversation going on between user and the model, right? So yeah. Okay, let's look at the final implications. Implications for system and agent builder. I think you can see experimental results with additional simulation, recap and snowball. So here also you will see the same things, that GPT-4o mini and 4o are failing miserably. Similarly, for implications for LLM builders, unreliability of models when changing assistant temperatures and user temperature. Guys, just look at the temperature difference and see difference in full and concat. This nothing looks consistent in the whole thing. Nothing looks consistent, right? So what is the implications for NLP practitioners? They say that our experiments have demonstrated that models' behavior to single and multi-turn chat are completely different, right? So one thing is pretty clear: we need to work a lot on this multi-turn chat conversation thing. We also need to work on interpretability to see how actually a model is thinking in that way, right? Because till we don't get to know about in depth, we study about interpretability, we won't be able to solve this problem, right? I think I recently even saw a tweet about how GPT-4o, like I think O3 mini was able to turn down the instruction that was given by user to shut down the system. It decided to sabotage that, and print skipped shutdown. And I think the main reason can be because the model has been trained, these thinking models have been trained to block all the obstacles that come in the way, right? It thought that as an obstacle coming between its task completion and decided to block it. Are we entering the Ultron age? Let's see. So conclusion overall is this: in this work we conduct a large scale simulation of single and multi-turn conversations with LLM and find that on a fixed set of tasks, LLM performance degrades significantly in multi-turn under specified settings. LLMs get lost in conversation, which materialize as significant decrease in reliability as models struggle to maintain context across turns. So guys, I think in general also, you guys can now decide how you guys want to complete a task using a LLM. You guys can decide that. So yeah, overall, I would recommend you guys to go and read this paper. And this part, I have not covered it, this implications of users on conversation system. You should read this because this is for people like us, right? If a conversation with an LLM did not lead to expected outcomes, starting a new conversation that repeats the same information might yield significantly better outcomes, right? So remember this. Consolidate before retrying. Since LLMs are ineffective at dealing with information dispersed across multiple turns, consolidating instruction requirement into a single instruction is an effective strategy to improve the model's aptitude and reliability. Okay, so when a user notices that a model is lost, they can ask, please consolidate everything I've told you so far, then bring the response to a new conversation and need the manual consolidation. So it's fine. So these are the two recommendations for users like us who use LLMs in their daily life for tasks, right? So yeah guys, that was it for this video. I hope you guys learned something new, something interesting, because apart from technical stuff, this was also a mind-blowing paper from even a user perspective who uses these models for their daily life. So yeah guys, thank you for watching the video. Thank you and have a nice day.